To play the game, a student spins the spinner twice and adds the two numbers that spinner lands on. If the sum is greater than or equal to 5, the student wins a prize. So my daughter AJ is going to help me with this one. We're going to take turns spinning the spinner twice. And as we spin, make sure you're recording on your notes page. All right, so you want to go first?
Mm-hmm.
Okay. Let's call out a 3. Go ahead and spin again. And 3. Okay, I get to spin twice.
I win a prize.
Hey, don't let the paper move, would you? Hold the paper still for me. 1 and 4.
Wait, exactly.
1 and 4.
Wait.
1, 4. Okay, you go.
Oh.
Here, I can hold it. She spun the spinner right off the paper. Good grief. Okay, try that again. Oh, that was a weenie spin. Redo. Okay, 4. Hold on. Ow, stop hitting the pencil. We may have to fire her from this job.
And
1. That was a weenie spin too. Okay, new rule. It has to go all the way around the spinner for it to count. Come on.
Okay.
Gosh.
The
1.
pencil was in the way.
No, I don't think the pencil was in the way. 1 and 1. Okay, here, then you hold it so it's not in your way.
Thank you.
3 and 2. Okay. 1 and 4. 1 and 1. I'm calling that was a spin. Sorry. 2. Oops, you missed it. And 3. 3. I'll do that again. 3 and 2. 3 and 1. 4
2
and 2. 2 and 3. Here, take the pencil. 4 and 2. Oh, sorry. It's early. We're struggling today. All right. How many more spins we have, Colton?
2.
2. Okay. 1 and 3. We'll say line. Okay. 2 and 3.
That was actually a 4 on a...
All right. We're going to pause and figure up some data, and then we'll answer some questions. All right, let's answer some questions over our last game. Out of the 15 turns, how many times was the sum greater than or equal to 5? It showed up 11 times. Which sum occurred most often? That was a sum of 5. Which sum occurred least often? We actually had a tie, which was a sum of 2 and 4. If students were to play a lot of games, what fraction of the games would they win? So based on what we found when we did it, we would expect them to win 11 out of 15 times. Name a sum that would be impossible to get while playing the game. AJ, what's a sum that's impossible to get?
1.
1. What's another one? Or could you get 100?
No.
No. So really there's lots of
9.
options for numbers you couldn't get, right?
Yeah.
Okay. All right. Let's move this paper. Which event is certain to occur while playing the game? So we're talking about the sums of the numbers. So if we look at all of the possible sums and we want it to be 100% a possibility, we could say getting a sum of 2 because that's the lowest. Or let's change this word up. A sum between, we could say 2 and 8 because this is the lowest sum you can get and this is the highest sum you can get. All right. Based on your experiment of playing the game, what is your estimate for the probability of getting a sum or 5 or more? And that was our 11 out of 15, which when we change that into a percent, if we want to show it that way, would be about 73%. And then based on your experiment with playing the game, what is your estimate for the probability of getting a sum of exactly 5? When you count all of those up, 5 occurred 8 out of the 15 times, which would be about, we'll say 53%.